If you want to know how to select the correct resistor to protect your LED from burning up, you need to know about Ohm's law. Stick around to the end and I'll show you a really clever way to remember it. But first, let me show you the exact answer to your question. I jumped online and found the forward voltage for a red LED off of a data sheet. It tells me it is 2 volts. The other thing I need to know from this chart is the forward current, which happens to be 20 milliamps. So in our case here, our supply voltage is subtracted from our LED voltage divided by the amount of current that this LED uses. So in our case, the Arduino is supplying 5 volts, the LED requires 2 volts, and the LED requires 20 milliamps or 0.02 amps. And that should get us 150 ohms. So I made this simple circuit. This whole side here is 5 volts. This whole side here is 3 volts. So we calculated this to be 150 ohms. I had a 220 on hand, and we can see that works. So the forward voltage on a blue LED happens to be 3.5 volts. That makes this resistor needing to be 75 ohm. And we can see it works. But when we drop down to this side here, with a forward voltage of 3 volts, we actually don't need a resistor. And you can see they're about the same brightness. Now, another thing we can do to kind of prove this to ourselves is that I'm going to pop out this 100 ohm and I'm going to put in 10,000 ohm or 10K, and you can see how much weaker it is. And we can use this for various concepts later. This is how I remember Ohm's law. V is voltage, and that's an eagle. And that happens to be flying above a rabbit, which is resistance, which is also flying above an Indian. And that's how we represent current. So if we go down to this equation here, the eagle looks down and sees that the Indian and the rabbit are on the same plane. So V equals IR, or voltage equals current times resistance. Now, when the Indian looks out, he sees the eagle happens to be above the rabbit, or voltage over resistance. And in our case today, we are solving for resistance equals the voltage over the current.